Group 4 and Problem 4. As you see, the constraints in your original problems are all less than and equal. So according to simplex method, we should add a slug variable in each constraint to convert the original problems to the standard form. As the slide shows, x3, x4, and x5 are slug variables. We also draw the graph and obtain feasible region. After doing this, we assume our basis variable to be x3, x4, and x5. Non-basis to be x1 and x2. So both x1 and x2 equal to 0. So the initial BFS is 0, 0.
When solving LP in matrix form, first write all relevant matrices for basic and non-basic variables. There are 4 steps when solving LP in matrix form. Step 1. Finding value of basic variables and optimal objective function as shown here. For a max problem, the optimal objective function value must increase in successive iterations to know if we are solving correctly. Step 2. Checking for optimality using reduced costs, Zj minus Cj, for all indices of the non-basic variables. Choose the smallest number and the corresponding non-basic variable as variable that enters the basis. Step 3. Checking for unboundedness. For the chosen variable, check for unboundedness. If B inverse into coefficient of the non-basic variable is greater than or equal to 0, then it is not unbounded. If B inverse into coefficient of the non-basic variable is less than or equal to 0 for a max problem, then stop as LP is unbounded. Step 4. To find the variable that blocks the chosen variable from increasing further, we do the minimum ratio test. This is done by dividing each element of B hat, that is B inverse B, by each element of A hat that is got from the previous step. Ignoring negative or 0 elements of A hat, minimum of the ratio test is obtained. The basic variable corresponding to this is the blocking variable and must leave the basis. Now we have the entering variable from step 2 and leaving variable from step 4. Update all matrices with new variables and proceed to step 1 and continue as before. An optimal solution is reached when in step 2 all reduced costs are greater than or equal to 0. At that point, the variables in the basis give the optimal solution to the LP.
This is the initial simplex table. The first row corresponds to the values of Zj minus Cj, which are non-zero only for non-basic variables. Basic variables in this table are x3, x4, x5. The non-basic variables in this table are x1 and x2. We denote the column below each variable by y. For example, column under x2 is y2. To check optimality, since this is a maximization problem, the solution is optimal if and only if the values of Zj minus Cj for all non-basic variables are greater than or equal to 0. But here both non-basic variables have negative values of Zj minus Cj, so the solution is not optimal. Since x2 has the most negative value of Zj minus Cj, we are going to choose it as the entering variable. To determine which variable is going to leave the basis, for each row of y2 we need to calculate values of right hand side divided by non-zero values of y2. The result of this division is shown on the ratio column. The basic variables which correspond to the smallest positive value of ratio column should leave the basis. So here x4 is going to leave the basis. In this iteration, mechanism is the same as the first table. Since not all Zj minus Cj's are non-negative, the solution is not optimal. x1 leaves the basis because it is the only variable that has a negative value of Zj minus Cj. x4 has the least positive ratio, so it leaves the basis. Here again, since not all Zj minus Cj's are non-negative, the solution is not optimal. x4 leaves the basis because it has a negative value of Zj minus Cj. x4 has a positive ratio, so it leaves the basis. This is the last tableau. Here, since all the basic variables have positive values of Zj minus Cj, the solution is optimal. x1, x2, and x4 are basic variables with values of 3, 8, and 4 respectively, and the optimal value of z is 38.
Using linear geometry, the simplex iterations explained earlier have been illustrated for better understanding and clarification. Thank you.